Hi, I'm Abhishek Garg, and I'm going to show you my final project for Electrical Engineering 47 at Stanford University over the summer of 2011. So here it is. This is my MP3 player, and it's specifically designed for running. You put it in your pocket at the beginning when you go out running, and you only have to take it out when you're done running. That's because it fits in your pocket, and the buttons pop out a little bit, and the wheel also pops out, so you can feel it while it's inside your pocket, and you can use those two things to adjust your music. In a previous video, I demonstrated how to use it, how to change the song, how to increase the volume, how to play and pause, and so in this video, I'm going to tell you how it works and how I built it. So I'll start by going over the components we have here. We have a battery, and this battery is in a battery slot. So this is a battery that outputs 1.5 volts. This battery slot, it also converts the voltage to 5 volts. And so it converts to 5 volts, then it sends it to a regulator inside the microcontroller. Under that yellow wire is where the wire from the battery goes, and there's another voltage regulator on the microcontroller, which is that green thing, that will step down the voltage from 5 volts to 3.5 volts, which is the voltage necessary to power all the components. So what is a microcontroller? Well, a microcontroller is a device that takes an input voltage coming from the battery in this case, and it decides what to do with that voltage. It decides where to send that voltage and how much of it to send. So doing that, it becomes kind of the brain of, in this case, the MP3 player. So the microcontroller right here, the green, gets voltage, and all the other components are attached in some way to the microcontroller. So the microcontroller will get power through the battery, and the solar panel will power the battery. The solar panel will output between 3.5 and 6 volts, depending on the lighting conditions, to the battery. And I attached a diode, which is something that allows current only to flow in one direction, so electricity will only go in one direction and not the other. I did that so that the battery does not overheat the solar panel and cause any problems. So the solar panel is charging the battery, and it's a rechargeable battery, and this was very difficult. I spent a long time thinking about it. I talked to my professors a lot about how to recharge a battery, what voltage you need. I tested it, and I found that this voltage does recharge the battery, and another problem we faced was how to monitor the charge in the battery so we don't overcharge the battery and blow it up. And so what you should do if you're considering a project similar is look on my wiki page, and I explain how to make a circuit to monitor the charge in the battery to make sure that the battery doesn't overcharge. And because I didn't have time to fully implement that circuit, it's manual right now. The switch right here that turns the MP3 player on and off, if you turn it to the left, then it'll start recharging the battery. And so you can manually recharge the battery when you want. You just put it out in the sun, flip the switch, and it'll start recharging your batteries. You just have to make sure that you don't recharge them for too long. So when it's not working, when there's not enough charge in the battery, just recharge it, and when it does start working, just stop the recharge. And if I had more time, I would fully implement that battery recharging circuit, but I didn't have time to this time. Basically, it consists of a transistor that will step up the voltage from the solar panel to the battery, and you control that transistor using the microcontroller. So when the battery is fully charged, you check that using an analog input pin. When the battery is fully charged, which means it's over 1.6 volts in the battery, then you would turn that transistor off. When you have less than that, you would turn it on to recharge the battery. And so that would automatically recharge the battery whenever you need to, and that would take care of all your problems. And so if you want to do that, just look on my wiki page. I have some more information. And so we have a button, of course. We have a wheel, and I made this in room 36 in the PRL lab, the product realization lab, and it's attached to a rotary encoder. So you turn this, and the rotary encoder will send a signal to the microcontroller of different voltages, either no voltage or some voltage, and so the microcontroller will know when you're turning the wheel and in which direction. And so this wheel is made out of wood, and I designed the wheel in a program called SolidWorks, and I printed it out using a laser cutter. So a laser cut all the grooves in the wheel, and it put it on the rotary encoder. And I have a button. You just attach the button from the microcontroller, of course, and when the button is pressed, no current will flow. When the button is not pressed, current will flow, and so you know when the button is pressed and when it's not pressed. And so we have an SD card to store all the songs that you want to listen to, and it was really difficult to solder it on because I took off the breakaway headers, which are some small pins that come out, because I wanted to make it smaller. With this whole thing, I wanted to make it very small and compact. And so this also attaches to the microcontroller, and in the back right here we have a MP3 decoder. So the microcontroller sends the MP3 decoder information, and that decoder puts out a voltage to the headphone jack right here, and you can just plug in headphones or any speakers to that, and so the MP3 decoder decides what kind of voltage to send to the headphone jack, and so the headphone jack will get that voltage. It has a magnet inside the speaker, and depending on what voltage the headphone gets, the magnet will have a specific amount of strength, and it'll move a plastic disc. And so when that plastic disc vibrates, it creates sound. And depending on how much voltage is sent in at what time, you can control how that disc moves and what vibrations are created, and so you can control music. You can listen to music through that. And so probably one of the biggest challenges in this whole thing was getting it to be so compact. As you can see, it's just a jungle of wires in here, and I soldered each one individually, and it took many hours, but I like doing it, so it was a lot of fun. As you can see, there's just wires going everywhere. Each of the components has many wires going through, especially the SD card and the MP3 decoder in the back. So there's a lot of wires going everywhere, and it is difficult and tedious to get all the wires in. And so another difficulty with something so small is getting the button to stay in place and getting the wheel to stay in place. So I borrowed some super glue from a friend, and I put everything in place with super glue, and so everything worked quite well. I found this wheel, so I put it under the battery just to give it some support so that when you push it down it doesn't fall through. It has something to hang off of. And so that really helped. And I used a laser cutter in the lab to cut some acrylic. That's how I cut this hole and the hole for the button and all the holes on here. And that really helped. The laser cutter is very convenient because it allows you to cut circles in the middle of a piece just like this. And it was a challenge making the case, and if I had more time I would make the case more aesthetic, but I made it transparent so you can see inside and so the solar panel can get some charge. And so I left some space for the switch, and you can put in a USB right here to change the program if you want it programmed differently, if you want some different settings. You can write your own program and put it through here. And you can also power it using the USB right here from your computer or through the